So things that maybe aren't linear, meaning we have more than an exponent of 1 on x, and we're subtracting these things, we're adding these things, we're simplifying these things. A lot of this stuff is from Algebra 1. So in our notes, technically the unit's called factoring. It doesn't match that in your goals packet because I didn't make the goals packet, the district did. So that's why it says higher order polynomials on there. But we're factoring this unit. That's what it's all about. And before we break stuff down, we have to figure out how it goes together. So that's what we're doing today, is adding, subtracting, and multiplying things that look like this. So if we look at this first one, and we multiply just the 3 and the 6, what number do we get? 18. Okay. And then exponent rules, x squared times x cubed. How do we handle this 2 and the 3? We add them. You guys might have heard the phrase base, add from Algebra 1. That's what we're doing here. Our bases match, we add the exponents. And that's it. Same kind of vibe for the second one. We add our exponents. This is really x to the first times x squared. So we get x to what power? 3. Perfect. Next one is more stuff that we're going to be doing today. When we add or subtract things like this, we're looking to combine like terms. So we're looking to see if this 3x can be combined with something else times x. Well, I see this x here. What's 3x plus x? 4x. It might be helpful for you to cross out as you go. I'm highlighting so you can kind of see what we're putting together, but whatever works for you. And then we look at the 4, the constant term. What goes with the 4? Negative 12. 4 minus 12 is negative 8. Then we look at the 7x squared. Negative 7x squared minus 2x squared is negative 9x squared. Watching those negative signs there. And then the plus x cubed, he doesn't have a friend to go with. He just hangs out by himself. This is completely simplified. What's up?
Is there a certain order that you put it in?
Yes, there is a certain order, and we'll talk about what that order is called later. But for now, I want you to write these in descending order based on your exponents. So we put the biggest exponent first, then we work our way down. So we put x cubed, then I put my x squareds, then my x's, and then my constant term, my number. Great question. So yeah, we will be reordering these things and putting it into standard form is what we call that, Ava.
Why didn't we do it like the 284? So when we had x to the exponent of 2, we added, negative 7x to the power 2 and then x to the power 3 or something.
Yes, so for your exponent rules, when you're adding things like this, like terms, your exponent stays the same, and then you just change the coefficient. So this is 1x squared plus another x squared. We get 2x squared. But when you're multiplying, that's when you change your exponent.
Oh, so we did it like this because we're not multiplying.
Right, we're adding.
Okay.
So we just add the number out in front. Any other questions? And I have a anchor chart that I'll put up at the end of the hour that has all of these exponent rules on there. So I'll leave it up for the unit in case you need a refresher on how exponents work. But questions on the warm-up. That's basically what we're going to be doing today. So we call these things a polynomial. So polynomials are expressions that have constant terms, variables, and they can have exponents. Does anyone know what a constant term is? Go ahead.
Is it just ones without a variable?
Yeah, it's just a number. So our constant term in this last example is that negative 8. So your constant term is a single numerical value or term. So that's a number, could be a variable equal to a number, something like that. Constant term. We call it a constant because it stays at the same value no matter what our variable is. Doesn't change. And then we can talk about monomials using prefixes. What does mono mean? One. So this is one term. Monomials have one term. So it could be like 3x or 2x or just x. Has a term with a variable. Monomial is 1. Binomial is 2. So we essentially take a monomial and we add it to a constant term. So 2x minus 1 or 3x plus 4, etc. You won't ever really have to classify these things, but when we go into later in the chapter, I'll talk about specifically binomials a lot. So just kind of get used to the language. Trinomial, how many terms do we think? 3. So now we could bring in like an x squared, 3x squared minus 2x plus 7. And when we're counting up the number of terms, we're counting like unique terms in the simplified version, meaning we want to say that it's a binomial if it was just x plus x, because we would simplify it and it would be 2x, so it would be a monomial. So we're only counting up terms in the simplified version. And we're going to take these things today, really these 3, monomial, binomials, and trinomials, and we're going to add and subtract them, and we're going to multiply them together, and the rest of the week we're going to be dividing them. And anytime we do these operations, like I said in the warm-up, we want to put our polynomial back into standard form. So this is where it's simplified, meaning your like terms are combined. And the degree, the exponent on your variable is dropping from left to right. So if you look here, this is like the general notation for polynomials. You might see this in later classes, but we start with an exponent of n, and then we drop it to an n minus 1, a number minus 1. And then we keep dropping it until we get just 1 in our exponent and 0 in our exponent. And then all those a's out in front are just your coefficients. So I would also get used to that word. These a's right here are called coefficients. That's just the number in front of your variable. Coefficients. So what's up, Ava?
What does the lower thing mean?
This is a subscript. All this means is it's your first coefficient. And it says a sub n because it goes with the exponent that has n. Don't worry too much about this. You will never see this form again unless you take a higher level math class.
Okay.
All you need to know is that your degree drops from left to right and it's simplified. Okay? So let's figure that out for these 3 examples. This first one, are all of the like terms combined? Is this thing simplified? Yeah. Is my degree dropping from left to right? Yeah, I go from 8 to 2 to 1 to 0. So this would be in standard form. The second one, are all of my like terms combined? Yeah. Is my degree dropping from left to right? No. I have a 2 and then an 8. So this would not be in standard form. We would have to switch those two, swap them around for it to be in standard form. And then what about the next one? Do I have any like terms? Yeah, these 2 middle pieces. So again, this isn't in standard form, and we would have to combine those 2 terms if we wanted it in standard form. Questions on standard form? Anytime we write down a polynomial, it should be in standard form. Always. So, we can add and subtract 2 polynomials like we did in the warm-up by combining like terms. So again, most of this is going to be Algebra 1 review. The more interactive you guys are, the faster this will go. So the more you show me that you know from Algebra 1 and you remember this stuff, the quicker we'll get through the lesson. So, right now we have two binomials being added together. Here's a binomial plus a binomial. Are these parentheses really doing anything? No, everything's addition. So let's drop the parentheses so we can start combining like terms. What goes with the 14x? 3x. 14x plus 3x? 17x. Then negative 6 plus 10? Positive 4. That's it. Drop your parentheses if they're not doing anything. Combine like terms. I'm going to skip down to this one. Here, are the parentheses doing something?
Yeah.
Yes, they're handling a negative. This minus sign goes for the entire set of parentheses behind it. So what should we do with that negative? Distribute. I'm going to bring it into each piece, each term in those parentheses. Same thing with the other negative. I'm going to bring it into each term. So the first trinomial, the parentheses don't matter there. So I'm going to just rewrite that as it is. And now I'm starting to be careful with my signs, and I'm going to carry this negative. Negative 5x cubed minus 2x minus 4x, and then minus a negative 5, so plus 5. Now we have something that we had in the warm-up. We combine like terms and simplify. As I do this, I'm going to start reordering. So I'm going to look for my highest exponent. It's that 3 there. So this is my first term. Does it have a buddy that it goes with? Yeah, the 5x cubed. So we would get negative 6x cubed. Now I'm looking at the exponent of 2. Does this 9x squared have a like term? No, so it stays the same. Now we handle our x's. Negative 2x minus 4x. Negative 6x. And then the constant term, negative 7 plus 5.
Wasn't it negative? Oh, sorry.
Yeah, we had to switch that sign. But yeah, negative 2. And that's it. So I typically like to reorder as I'm combining like terms because it saves a few steps. But you do what you need to do. And again, you can highlight, you can cross out. You don't have to do anything up here if you don't want to. Hardest part is just keeping track of all your stuff. So do whatever you need to do to keep track of all of your terms and what you've combined and what you haven't. Questions on that one? Okay, let's do this one, and then I'm going to have you guys do the last 3 on your own. For this first piece, are my parentheses doing something? Yeah, what are they doing? What should they be doing? Yeah, multiplying by that 3. So I'm going to distribute this 3. That's step 1. 3 times 4x squared is 12x squared. 3 times negative x is negative 3x. And 3 times 7 is 21. The second set of parentheses, are they doing something? Yeah, what should I distribute in there? Negative 2 into the whole thing. I'm bringing the negative with it. Okay? So this would be negative 2x. Negative 2 times negative x cubed is positive 2x cubed. And then minus 16. Perfect. And then we combine. Let's look at my x cubes. Does the 2x cube have a buddy? Nope. So we write him down. He stays the same. What about my 12x squared? Nope. He's by himself. So plus 12x squared. What about my x's?
Yes.
Negative 3x minus 2x.
Negative 5x.
Negative 5x.
Plus 5.
Yeah, and then my constant terms, 21 minus 16, positive 5. Questions on that one? Okay, I want you to do the 3 that we skipped on your own. I'm going to write my answers in my work up here, so as you're doing these, check as you go. Okay, but most of this is review. If you need help, raise your hand, but we should feel okay about this. Okay, so I'm going to write my answers up here. You check as you go. No, it's just weird. This column is mostly sophomores except for the very last one is juniors because it starts the alphabet. So what's your last name? And M-O and then sophomore or junior? So you're going at 150. Yeah, it's kind of weird to read because it says 10-11, but it's really not. It's just 10 grade plus 3. What did I just say? 150? Yeah, 150. Hey, done?
No. Is this one?
Yes.
Okay.
Yeah, good.
Just the unit title because I was.
Yes, it's kind of mixed up because the district makes that and I reorder things a little bit different. Give you about 1 or 2 more minutes to complete these. Oh yeah, you are too. Oh. What time are you supposed to go? You're a junior. Well, don't go. And you're from the keep my name out of it.
I was already planning on it because I was gonna go.
What, you don't think you look, oh.
No, I was gonna go here like.
What's the opposite? I'm so bored. I guess so 10:40. Yes, because that's at the very end of 5th hour. And 5th hour ends at 10:53. Oh, that's in here. Yeah. Yeah. Okay. Anyone have questions over these before we get moving on to multiplication? On like a thumbs up, sideways down, how do we feel? Hopefully we're all here, mostly review. Okay. Stepping it up just a little bit, multiplication. Nothing crazy new because we already did this a little bit. But if we wanted to multiply this monomial by this binomial, what should I do? What are those parentheses telling me to do? Distribute, yeah. Negative 2x squared times 3x is negative 6x cubed. And then 7 times negative 2x squared, negative 14x squared.
Wait, is there gonna be like any graphing this unit?
Nope. Next unit, yes. But not this unit.
Like these though?
Not with this high of powers. We'll only go up to 2 for graphing. Maybe we'll go up to 3 for graphing. Next one, same thing, we distribute. What would our first term be? What's 3x squared times x?
Why isn't it cubed, the 14x? Negative 14x.
Because it was just an x squared and we didn't have an x here.
So we only like add the 2 exponents when it's both over an x?
Yes, when they're on that same base, but they both have an x, yes. And then for my last term, 15x squared. So this is a monomial times a binomial. We can also do a binomial times a binomial. You guys did this in Algebra 1. How do we handle something like this? What's the acronym we use? Starts with an F. FOIL. We are foiling. Yay. So the F stands for first. We multiply the first 2 terms. x times 4x. 4x squared. What's the O stand for? Outer. So we take our two outside terms. X times 1 is just x. What about the I? Inside. 2 times 4x is 8x. And then the L stands for last. 2 times 1 is 2. And then we combine. My 4x squared stays out in front. I combine my middle two terms to 9x, and then plus 2. Questions on foiling? We're going to do the same thing for the next one. The F stands for first. Negative n times 7n is negative 7n squared. Outside, watch your signs here. Negative n times negative 3 is positive 3n. Inside, 3 times 7n is positive 21n. And then 3 times negative 3 is negative 9. And then we combine. The negative 7n squared stays. We get plus 24n as our middle term, and then minus 9. Questions on binomials times a binomial, so foiling, or distributing? Any questions on those before we bump it up another level?
Do we have like an exercise paper for this kind of like marbles?
Like an extra piece of paper?
No, like stuff where you can try this more.
I can find one for you, but it's all your homework tonight, is all this stuff.
Okay. So,
But I can get another piece of paper if we need it.
because this is gonna be delta math.
Mm-hmm. I'll give you a hard copy. Yeah. Okay. Next ones are binomials times a trinomial. We do something very similar. We take each term of our binomial and we multiply it by each term of the trinomial. So if I look at just the 2x times x squared is 2x cubed. So that handles this piece. Then, bless you, 2x times negative 3x is negative 6x squared. And then 2x times negative 5 is negative 10x. So I just take my first term and I multiply it by every term of my second polynomial.
So do we not use the one at all?
I'm not done yet. We do the same thing for one. I take it, I multiply it by each term of the second one. So you would get x squared minus 3x minus 5. So again, just taking each piece and multiplying it by each piece of my second one. Then we combine. 2x cubed doesn't have any friends, so it stays. We can do negative 10x minus 3x and negative 6x plus x squared. So we end up getting negative 5x squared from the pinks, minus 13x from the teals, and then minus 5 for that constant term. Questions on that one? We're going to do this one together. These two you'll do on your own, and then we'll have time for homework. So this next one, a plus 1 cubed. Can I just say, okay, this is a cubed plus 1 cubed? No. We cannot distribute exponents like that. Instead, we have to think of this as a plus 1 times itself 3 times. So we think of it like this. A plus 1 times a plus 1 times a plus 1. We take the first two. We FOIL. First is a squared. Outside is 1 times A, so just A. Inside is 1 times A, so just A. And then 1 times 1 for the last piece is 1. Be careful here. This whole thing is still being multiplied by this whole thing. Although we FOILed, we're not really dropping our parentheses because we still need to multiply in here. And before I multiply every piece of this trinomial by this binomial, I'm going to simplify. What does my middle term become? 2a. So a squared plus 2a plus 1 times a plus 1. And then we do the same thing. First term times both other terms. So a squared times a is a cubed, and a squared times 1 is a squared. So that handles the first piece. Second piece, 2a times a is 2a squared, and 2a times 1 is 2a. And then the very last piece, 1 times a and 1 times 1. We get a plus 1. And then we combine. My a cubes can't be combined with anything. How many a squareds would I have? What's my coefficient on a squared? 3. 3a squared. And same thing for a. 2a plus a is 3a. And then plus 1. Questions on any of those? Okay, I want you to try the last two on your own or with the people around you. Check your answer with mine up on the board, and then you have the rest of the time for homework on Delta Math. Hold on, Ava, give me a second.